students, I hope all of you are doing good, and today I am here with the third video of the video series on understanding elementary shapes, class 6th maths. And in today's video our agenda is to learn about triangles. Now triangles are going to be super duper important, not just for now but also for your higher classes to come. So I hope you understand how important are triangles. So let's not waste any further time and get to the point. So let's get started. So now that we have learned about angles, it's time for triangles. So what do you think triangles could be? Triangles. Tri means three. So three angles. So it is a geometrical shape which has three angles. Now let us think of some examples. Whenever you draw the picture of a hut, if you look at the upper portion of the hut, so the roof of the hut basically, that is in the shape of a triangle. Similarly, when you think of placing a ladder against a wall, let's say that this black thing represents a ladder. You have placed the ladder across the wall and this is your wall. So when you look at it from the side view, so this gives you the appearance of a triangle again. So this is the wall, this is the wall, this is the ladder, and this is the distance between the wall and the ladder, that is the floor basically. So these three things together make a triangle. So a triangle is a polygon with three sides. That means it is, what is polygon? Polygon is a geometrical shape which is a closed figure, completely closed, and it is made up of only line segments. So triangle is that type of a polygon which is made up of three line segments. So there are three sides in a triangle. And how do we denote a triangle? In short, we write a triangle like this, triangle ABC. So this symbol represents triangle. Now there are three important parts of a triangle: sides, vertices and angles. So when you look at the image of this triangle ABC, what are the sides of this triangle? The sides would be AB, BC and AC. So sides represents the line segments which form that triangle. So what are the vertices? So vertex refers to that point where two sides meet. So you see point A is one vertex because AB and AC meets at A. Similarly, B is another vertex because AB and BC meets at B. C is another vertex because AC and BC, they meet at C. So therefore points A, B and C are the vertices. And what about the angles? So these are the angles, that is the orientation between any two sides is an angle. So since there are three sides, there are three angles. What are the angles? Angle A, angle B and angle C. So three sides, three angles and three vertices make a triangle. Now there are many types of triangles. Now first we talk about the types of triangle based on the sides, like if the sides are equal or the sides are not equal. Based on that there are three types of triangle. First type is scalene triangle. So a scalene triangle is the one where all the sides are unequal. So you measure all the three sides. Let's say that the name of this triangle is ABC. So in this type of a triangle, the length of AB is not equal to the length of BC, is not equal to the length of AC. So each of their lengths are different. That is called a scalene triangle. Second type of triangle is an isosceles triangle. So in this triangle, two sides are equal. So out of three sides, two sides are equal. For example, if this is a triangle ABC, so in this case AB is equal to AC. So AB is equal to AC. However, BC is not equal to AB. BC is not equal to AC as well. So any two sides are equal in this case. Now since these two sides are equal, in this type of triangle we find that two angles are also equal. So these two angles are called the base angles, because these are the angles which are formed on the base of the triangle. Base means bottom. So we say that in this case angle B is equal to angle C. So this is isosceles triangle. Iso word is used for similar. So in this type of triangle there is some sort of similarity because two sides are equal. And then the third type is equilateral. That means all the sides are equal. Equi means equal. So all sides equal, therefore all angles are also equal. So if this is a triangle ABC, so in this case AB is equal to AC is equal to BC. So AB equal to BC equal to AC, and also the three angles are equal. That is, angle A is equal to angle B is equal to angle C. So we have scalene triangle where all sides are equal, isosceles where two sides equal, and equilateral where all sides are equal. Now, on similar lines, we can also categorize triangles based on the angles, based on the type of angles which are present in a triangle. So on this basis also, the triangles can be divided into three types. So the first type is acute-angled triangle. So what is acute angle? Acute angle is that angle which is less than 90 degree. So if we have a triangle where all the three angles are acute angles, then that triangle is called acute-angled triangle. For example, in this triangle ABC, and the measurement of angle A is less than 90 degree, measurement of angle B is less than 90 degree, measurement of angle C is less than 90 degree. If this holds true, then this triangle is called an acute-angled triangle. Similarly, you might have right-angled triangle where at least one angle is 90 degree. Now, can you ever draw a triangle where more than one angle is 90 degree? No, you cannot draw a triangle like that. You know why? Because there is a property that the sum of the three angles in a triangle is 180 degree. Okay, now if two angles are 90 degree, that means the third angle has to be 0, right? But that is not possible. How can we make the third angle 0? So therefore, we can never draw a triangle with more than one angle equal to 90 degree. So at the max, only one angle can be 90 degree. So any such triangle where one angle is 90 degree, that is called a right-angled triangle. And the third category is obtuse-angled, where one angle is greater than 90 degree. Now, do you think that two angles in a triangle can be obtuse angle? No. Again, the same reason, because one angle obtuse means the value of one angle itself is more than 90 degree. For example, in this triangle, this angle is greater than 90 degree. So 90 degree would have been somewhat like this. So this would have been 90 degree. So one angle is greater than 90 degree, but again, sum of the three angles should be 180 degree. So that means the other two angles should be less than 90 degree. So whenever one angle is obtuse angle, then that triangle is called obtuse-angled triangle. Whenever one angle is 90 degree, the triangle is called right-angled triangle. When all the three angles are less than 90 degree, it is called acute-angled triangle. So in this fashion, depending on what type of angles are present in a triangle, they can be classified into acute, right, and obtuse-angled triangle. Now, there could be a combo of these two types of triangles. For example, a right-angled triangle can also be an isosceles triangle, because, for example, let's take this example. This is a right-angled triangle. Why? Because there is one angle which is equal to 90 degree. So therefore, we have one angle as 90 degree. But at the same time, in the same triangle, we also see another property, that the length of this side BC is equal to the length of this side AB. So here we see that AB is equal to BC. This is also true, and at the same time angle B is equal to 90 degree. This is also true. Now, since these both conditions are true for the same triangle, so this triangle is right angled triangle, this triangle is also isosceles triangle. So together this triangle is a right angled isosceles triangle. So we can also have these kind of combos where depending on the sides we can say whether it is scalene, isosceles or equilateral, and depending on the angle we can say whether it is acute, right or obtuse. But not all the combinations are possible. So we will have a look at that as well. Let's look at this one. This is also a right angle triangle because we have a 90 degree here. But in this case, all the three sides are unequal. So this is a right angled scalene triangle. So let's check the possibility of combination between equilateral, scalene, isosceles and right angled, obtuse angled, acute angled triangle. Now, when we talk about a scalene triangle, it can be acute, right or obtuse. So basically a scalene triangle where all the three sides are unequal. This kind of a triangle can be an acute angle triangle, that is all angles are less than 90 degree. That is possible. So this is a scalene acute. This is a scalene right triangle. So that because one angle is 90 degree. And this is a scalene obtuse because out of the three angles, one angle is more than 90 degree. So therefore, a scalene triangle can be acute scalene triangle, it can be right angled scalene triangle, it can be obtuse-angled scalene triangle. Now when it comes to isosceles triangle, this can also be acute, right, or obtuse. That means you can have an isosceles triangle which is acute. That means all the three angles are less than 90 degree and two sides are equal. So this is acute isosceles triangle. It could also be possible that one angle is 90 degree, this angle is 90 degree and two sides are equal in length. So this is isosceles triangle which is right angled. This is also possible that one angle is greater than 90 degree, that is one angle is obtuse and two sides are equal. So this is obtuse-angled isosceles triangle. So in case of isosceles triangle also all the three possibilities are possible. When it comes to equilateral triangle, an equilateral triangle can only be acute because in equilateral triangle we want all the three angles should be equal. All the three sides should be equal, all the three angles should be equal. Now for all the three angles to be equal, they need to be less than 90 degree because the sum of the three angles should be 180 degree. So when all the three angles are equal, that means let us say that the value of each angle is x. So that means x plus x should be equal to 180 degree. So from this we can say that 3x is 180 degree or we can say x is equal to 60 degree. That means the value of each angle in an equilateral triangle is 60 degree. So there is no question of a right angled equilateral triangle because for a right angled triangle one angle must be 90 degree. But in an equilateral triangle all the angles are 60 degree. So an equilateral, a right angled equilateral triangle is not possible. An obtuse angled equilateral triangle is also not possible. Only an acute equilateral triangle is possible. So now that we have learned about the various types of triangles, we will try some questions. Question number 1. Name the types of following triangles. Triangle LMN with angle L. This M angle L means measure of angle L is equal to 30 degree. Measure of angle M is equal to 70 degree and measure of angle N is equal to 80 degrees. So let us try to draw a rough sketch of this triangle. So angle L is 30 degree. So first we draw angle L. Let's say this is 30 degree and this is angle L. Angle M is 70 degree. So let's say that this, let's call this point as, this is L, M, N. So now when we join this triangle, we see that this angle M is 70 degree and this angle N is 80 degree. Now these are not accurate measurements. We are just drawing a rough triangle. So what do we see? The measurement of all the three angles are less than 90 degree. That means what type of triangle is this? This is an acute angled triangle. Now since there is no mention about the sides, so we will not be able to decide whether it is a scalene triangle or an isosceles triangle. So we will not mention anything about that. Next one is angle XYZ, triangle XYZ with angle Y is equal to 90 degrees. So let's draw a 90 degree. So this is 90 degree and this is angle Y. And XY is equal to YZ. So if this is X and this is Z, so XY is equal to YZ. So what type of triangle is this? So here there is one angle 90 degree. So this has to be a right angle triangle. At the same time, two sides are also equal. So this is an isosceles triangle. So this is right angled isosceles triangle. Question number 2. Name each of the following triangles in two different ways. You may judge the nature of the angle by observation. Okay, so just by observation we have to tell which triangle is of which type. So the first triangle we see all the measurement of the three sides are different. So that means this is a scalene triangle. But at the same time regarding the angles we see that there is one angle which is 90 degree. So that means this is a right angled scalene triangle. Let's look at the second one. Here we see that the length of these two sides are equal. Both are 7 centimeters. So that means it is an isosceles triangle. And we also see that the measure of this angle is greater than 90 degree, because 90 degree would have been somewhat like this. So it is more than 90 degrees. So that is, this is obtuse angle. So this is obtuse angled isosceles triangle. Question number 3. Which of the following are models for perpendicular lines? Now what do we mean by perpendicular lines? That means when two lines intersect each other at 90 degrees, they are said to be perpendicular on each other. Let's say there is one line like this, there is another line like this. So both the lines are intersecting at this point, and also the angle that they make at the point of intersection is 90 degrees. So we can say that these lines are perpendicular to each other. So the adjacent edges of a tabletop. So if you look at the tabletop, you would see that this side and this side, these are the adjacent edges, the adjacent sides. So are they perpendicular to each other? Yes, they are, because when you look at a tabletop, the tabletop is like rectangular in shape, if we are talking about a general rectangular tabletop. So in that case, their adjacent sides are perpendicular to each other. The lines of a railway track. Well, when you talk about the lines, this is one line and this is another line, and these two lines, they do not seem to be intersecting each other. So these two lines are parallel to each other. So two parallel lines cannot be perpendicular to each other because they are not going to meet itself. And for two lines to be perpendicular, the first criteria is that the two lines should intersect, and that too at 90 degree. So therefore, the lines of a railway track are not models of perpendicular lines. Let's look at the next one. The line segments forming the letter L. So if you focus properly on the letter L of the English alphabet, you see that this line is perpendicular to this line, because both the lines intersect at this point, and that too at 90 degree. So yes, they are a model of perpendicular lines. The letter V. So if you look at letter V, here also these two lines intersect at this point, but the angle at which they intersect is an acute angle. So this is not a perpendicular line. Question number 4. There are two set squares in your geometry box. What are the measures of the angles that are formed at their corners? Do they have any angle measure that is common? Now, if you look at the two set square, you would see that both the set square have 90 degree in common. So for this set square, this is 90 degree, this is 60 degree, and this is 30 degree. So this is one piece of set square where the other two angles except the 90 degree, they are unequal. One is 60, the other one is 30. Whereas in the other set square, one angle is 90 and the other two angles are also equal. So they are 45 degree each. So which angle is common amongst them? So 90 degree is common. So one set square has 90, 60, 30. The other set square has 90, 45, 45. So which is the common angle? 90 degree is the common angle between them. So now that we have learned about triangles, it's time for polygon. So I told you that triangle also is a polygon. So what's a polygon? A polygon is not necessarily a triangle. It is any such geometrical shape which is closed and which is made up of line segments. In fact, your blackboard is also a polygon. So it is made up of 4 line segments. 1, 2, 3, 4. And it is also a closed figure. So the blackboard is a polygon. You think of a book. So book is also made up of 4 line segments. When you look at a book from the top view, that is also a polygon. The window pane, a kite. So these are all examples of polygons. So we can define polygon as a simple closed curve made up of only line segments. Now here you need to understand the meaning of each term. What do we mean by a simple curve? A simple curve means a curve which does not intersect itself or which does not cross over itself. For example, let's take. So here on the screen we have almost 12 geometrical figures, of which we have to identify which one is a polygon and which one is not. Now what do we mean by simple curve? Those curve which does not intersect itself. For example, if I draw something like this, a curve like this. So here this curve never crossed itself. But if I draw a curve like this curve is intersecting itself. You see, this is the point of intersection, this is the point of intersection. So this is not a simple curve. So a simple curve is one which doesn't cross over itself or which doesn't intersect itself. That is simple curve. That is, it doesn't come over itself. Okay, closed curve. So polygon has to be a simple curve, it has to be a closed curve, and it must be made up of only line segments. Only line segments. So let us look at the examples here. Number 1. Here this is a closed curve because it is a totally closed figure. So one criteria is satisfied. Is it a simple curve? Yes, because the lines, they do not cross over each other like these. So that is also satisfied. Is it made up of only line segments? Yes, it is made up of 4 line segments. So this is a polygon. Let's look at number 2. So here this is also a closed curve because it encloses this region inside. It is also made up of only line segments. There are 6 line segments which make this. This is also a simple curve because it doesn't intersect itself. So this is also a polygon. Let's move on to number 4. So number 4 is also closed. Is it made up of line segments? No. So since it is not made up of line segment, so this is not a polygon because it doesn't satisfy one of the criteria. Let us look at number 9. So in number 9 also, even though it is closed, but it is not made up of line segments. So this is also not a polygon. If you look at number 12, now number 12 is closed. Yes, it is closed. It is made up of line segments. Yes, 1, 2, 3, 4, 5, 6 line segments make it. Is it a simple curve? No, because it crosses over itself. You see, it is crossing over itself like this. So at this region, it is crossing over itself. So therefore, this is not a polygon. However, if you draw a similar figure like this, then it is a polygon. Because in this case, it is not crossing over itself. So this is a simple curve. So this would be a polygon. So in a similar way, try to identify all these images, whether it is polygon or not. So the 3 criteria: simple curve, closed curve, only line segments. If these 3 are satisfied, that means that figure is a polygon. Now when we talk about features in a polygon, again here we have sides, vertices, angles and diagonals. So sides, nothing but the line segments which form this polygon. So the line segments that form a polygon are the sides. So if you take the example of this polygon, let's name this as A, B, C, D. So here A, B, B, C, C, D and A, D. These are the sides of the polygon. If you look at this triangle D, E, F, then D, E, E, F and D, F are the sides of the polygon. Vertices, these are the points where a pair of sides meet. So for this one, points A, B, C, D, these are the vertices. For this triangle, point D, E, F are the vertices. For this pentagon, A, B, C, D, E, the vertices are points A, B, C, D, E. Because you see, A is a point where the sides AB and AE meet. Similarly, B is a point where the sides AB and CD meets. So similarly, all these points are the vertices. Angles, measure of orientation between 2 sides. So this is one angle, this is another angle, this is one angle which is orientation between the sides AB and BC. Similarly, this is an angle which is orientation between BC and CD. So a triangle has 3 angles. Similarly, this polygon has 1, 2, 3, 4 and 5 angles. Diagonals. This is the line segment that joins non-adjacent vertices. Now, A, B, C, D are the 4 vertices in this polygon. So A and B are adjacent vertices because they are lying side by side. So both A and B, they share a common side AB. Similarly, A and D are also adjacent vertices because they share the common side AD. But A and C, these 2 are non-adjacent. So they are not located next to each other. They are located opposite to each other. So any line segment which joins the non-adjacent vertices, that is called a diagonal. So similarly, AC and BD are the 2 diagonals for this polygon. What about this polygon? This is A. The adjacent vertices of A would be B and E. That means C and D are its non-adjacent vertices. So if you join A and C, this becomes a diagonal. You join A and D, this becomes a diagonal. You join B and E, this also becomes a diagonal. So a line that connects any 2 non-adjacent vertices is a diagonal. So these are the 4 important parts of a polygon: sides, angles, vertices and diagonals. So as we discussed, diagonal of a polygon is that line segment which connects 2 non-consecutive vertices of the polygon. So this is the most important catch here: non-consecutive vertices. Let us take examples of some polygons. So this is a polygon. First tell me if this is a polygon or not. Let's look at the criteria. It is a closed curve. Yes. It is a simple curve. Yes. It is made up of only line segments. Yes. It is made up of 5 line segments. So this is a polygon. Now in this polygon, which are the vertices? 1, 2, 3, 4, 5. So these are the 5 vertices. Let's name them as A, B, C, D, E. So for A, which are the adjacent vertices or consecutive vertices? That means the vertices which lie side by side. That means for those 2 vertices, there will be a common arm or a common side. For example, the next door neighbors for vertex A are E and B, because E and A are consecutive. Similarly, A and E are also consecutive. So the consecutive vertices for A are B and E respectively. So which are the non-consecutive vertices for A? A and C are non-consecutive vertices. So if you join them, you get a diagonal. Similarly, B and D are non-consecutive vertices. You join them, you get a diagonal. B and E are also non-consecutive vertices. You join them, you get a diagonal. E and C, they are also non-consecutive. You join them, you get a diagonal. So in this fashion, you can draw multiple diagonals for polygons. Now, how many diagonals you can draw, that changes depending on what is the polygon. So as the number of sides in the polygon increases, the number of possible diagonals also increase. Now let us look at these polygons. So these are the polygons with 4 sides. So therefore, how many diagonals we can draw? So here it was 5 sides. So this time you will see that you can draw lesser number of diagonals. Like here you also have a possibility of this diagonal. Okay, so here this is one possibility and this is another possibility. So there are only 2 possible diagonals in this case. You cannot draw more than 2. Similarly, here also this is one possible diagonal, this is another possible diagonal. You cannot draw more than these. Now you can try drawing diagonals for all of these polygons. Now they are all polygons with multiple number of sides. So try to draw diagonals for all of them. So that would not only help you to practice but also help you in better understanding of diagonals. Now let's talk about regular and irregular polygons. So when we talk about polygons, there are 2 categories again. Regular polygons where all sides and all angles are equal. So can you tell me an example of a regular polygon which we have discussed some time back? Absolutely. Equilateral triangle. So equilateral triangle is an example of a regular polygon. Why? Because in an equilateral triangle, all the sides are equal, all the angles are also equal. So this is an example of regular polygon. Similarly, when you look at this polygon with 5 sides, such that the length of all the 5 sides are equal and also the measure of all the 5 angles are also equal. So this is a regular pentagon. Why pentagon? Because it has 5 sides. Penta means 5. Here, what is this? It is a polygon with 4 sides where all the 4 sides are equal and all the 4 angles are also equal, and we call this a square. So we will learn about square, pentagon a little later, but these are all examples of regular polygon. Regular means all sides equal, all angles equal. So on the contrary, irregular polygon would mean that all sides are not equal, all angles are not equal. You look at this triangle. This is a right angle triangle. Here this angle is 90 degree, but these 2 angles are acute angles, that is less than 90 degrees. So all angles are not equal, all sides are also not equal. You look at this polygon. Here all angles are equal, all the angles are equal to 90 degree, but in this case all sides are not equal. So these opposite sides are equal and these opposite sides are equal, but the adjacent sides are not equal. You look at this one. Here all angles are not equal. So this is also an irregular polygon. So in order to be a regular polygon, all sides and all angles both should be equal. Now let us look at the types of polygon depending on the number of sides present in them. So a polygon with 3 sides, that means a polygon made up of 3 line segments, is called a triangle. Tri means 3. So 3 angles, that is triangle. A polygon with 4 sides, that is called a quadrilateral. The word quadri, this means 4. So that is quadrilateral. Now there can be many different types of quadrilateral again. A polygon with 5 sides. 5 is penta. So this is pentagon. Polygon with 6 sides. 6 is hexa. So this is hexagon. Polygon with 7 sides will be a heptagon. Hepta means 7. So hepta is 7, penta is 5, hexa is 6. Similarly, what would be 8? 8 is octa. So this would be octagon. So in a similar way, you can name a polygon depending on the number of sides present in it.
I hope you found the video useful. If you really liked the video, do not forget to share it with your friends. And if you think after watching this video, your concepts of this lesson became crystal clear, please do write in the comment section that my concepts are crystal clear. So I will meet you all very soon with a new video, with a new topic. Till then, stay home, stay safe, take care. Bye-bye.